Welcome to Digital Toolbox. This is the second installation in our polysurface waffle definition. So refer back to the first one to get to this point. We've just set a geometry as the sphere and used the box components to draw a grid underneath of it. In this video we'll go through taking the grid and splicing up the contours of our geometry. So the first thing we're going to do is zoom into these lines we previously created and figure out how many lines there's coming out of this output. So we'll use a logic list length, and that'll tell us how many lines there are in this list. So you can see, remember our input was 6 by 6 slats that we want for our waffle, and it's outputting 8. So that's the exterior ones as well, but we're going to subtract the beginning and end points. So I'll grab a one variable function. I'll just type in F1, and in this function I'm just going to do x minus 2. And that will take away those end conditions that we don't want for our waffle. After this one variable function, then we're going to pop it into a series so we can see what those numbers actually are. So the starting unit, we don't want it to be 0 because that would start it on the end, but we want those middle slats, so we'll start it at 1, and that will select 1 to the end, subtract that last one. So the R will go into C, and then you can see on the output 1 through 6 right there, and that'll give us the series of slats that we want. Then after the series, we're going to select those items individually. So that's under list item, and copy that down. And the I will be the input for our series, and then the items that we want to select, the L, the base list, is the lines that we created, those orthogonal crossing lines for the waffle. So you can see in the Rhino window, if we select both of these, it selects just those interior lines that we want for the waffle. I'm sure you can't see that in the video, but try it yourself and it should work. And then after that, we're going to want to extrude those up. So I'll double click, just grab the extrude button, and I'm going to put the base geometry as our list, and copy that for each of them. And then the direction is going to be in the Z unit, so I'll just grab the unit Z and throw that into both of these guys. The unit Z starts out with a 1 unit, so the unit we actually want to be related to our box corners in the beginning. So I'll zoom into the box corners and then grab a distance button, and here we'll just measure the vertical distance. So we'll start at the A point and then measure to the E point, which is the corresponding box corner above it, and then that D distance we'll take and throw into the Z unit, and you'll see they pop up right there. Once you have extruded those planes, then we're going to go under intersect mathematical B-rep plane, and that'll equivalently get the individual sections for us. So the P is the section plane, and that's the those extrusions we just did. And then the B is the input, the base geometry, which we're going to home run back to our geometry that we set for our waffle. So I'll zoom out and do that really quickly. And then once that one's set, we can copy that down so we don't have to go back to the beginning, and just associate that one with the second extrusion. So if we turn off these extruded planes, right click to unpreview, you can see these individual contours just like the contour command in Rhino for each direction. And then after that, we're going to create some planes. So the planar surface is right under surface freeform planar surface, and the E goes into the C section curves, and copy that down. And then we should be able to turn off the blue layer, and you can see right there our individual planes. So that's all we're going to do for this tutorial, create these individual section planes. The next one will be extruding them to our material thickness before we do the actual friction, the joints, to get the full waffle.